Hello, welcome to our Institute of Global Professionals free webinar. Good evening, everyone. Thank you all for joining and stay with us till the end. Once again, I am Aksar Rubani, core volunteer in IGP. Every day, some new participant joined with us, so I have to give little concept about IGP. Institute of Global Professionals serve student and community resource, providing social work and education for create a proficient generation. We have already completed 84 webinars successfully. We expect that you all are getting a little bit benefited in personal and professional life, and we wish that you all are remaining with us in long journey. I am cordially welcome you all. Today, we are presenting the webinar 85th on Spanish multiplication of algebra expression with two speakers, Dr. Clarence and Dr. Alder D. Alvaro. So let's start our program. Our first speaker is Dr. Clarence, completed doctorate degree of education and PhD in mathematics. Please give a warm welcome to Dr. Clarence, sir. Hello, sir.
Hello.
How are you, sir?
Good, I'm good. A little bit nervous.
No, no.
Do I have to start now?
Yes, yes.
Okay. Sure. No, no. Okay. Okay. I am Dr. Clarence de la Cruz Acuman from the Philippines. Currently, I'm teaching at Subic National High School in Subic, Zambales, Philippines. I graduated uh, my master's degree. I finished my master's degree at President Ramon Magsaysay State University and my doctorate degree at FIST International. So that's it. Thank you for this opportunity, and I hope you will learn something from the topic of mine that I will be discuss with you guys. Okay. The topic that I'm going to discuss with you is the Japanese multiplication of 2 to 3 digits. Okay, for the introduction, there are lots of ways to multiply numbers. One approach that has caught people's eye is the Japanese multiplication method. At first, it seems like something out of a magic show, but mathematics should never feel mystical to the point of confusion. And while magicians may never reveal their tricks, we think it is essential to lift the lid on just why these strange methods work. It's the only way to fully appreciate them. Is the Japanese multiplication method helpful? First, in the Japanese multiplication method, we are able to complete a multiplication problem by merely drawing a few lines and counting the points of intersections. Sounds too good to be true, right? Later on, you will see how this multiplication method will be helpful for each and every one of us. Switching between representations is a great way for your child to test their understanding of a particular method. It's one thing to know how to carry out a procedure, like long multiplication, but this is only useful when your child knows why that method works. Once they make these connections between symbolic and visual methods, they'll be able to apply their full toolkit of procedures in different situations. Next, some would say no need to use this because it's too simple. However, some pupils have difficulty in multiplication but very good in addition. As for my experience as a high school teacher, most of the students really having a hard time, especially in multiplying numbers with 2 to 3 digits or more. So I think most of the students uh, they use this addition of numbers to come up with their solution in multiplying numbers. This is the way of Japanese multiplication, adding the intersections rather than using multiplication. How does the Japanese multiplication method work? So let us have some examples. Okay, for example, we have 12 times 32. Remember that numbers are represented using place value. 12 means 1 10 and 2 ones. 32 means 3 tens and 2 ones. Then let us draw diagonal lines corresponding to the tens, and after leaving a gap, we draw more lines in parallel to represent the ones. It helps to use a different color. So for the number 12, we get, okay, for our example, we're going to use two colors, the blue ones and the red one. Okay, so we're done with 12. Uh, one One represented by the blue line and two represented by the red lines. All we're doing is taking the familiar place value representation of numbers and making it visual. Now let's do the number 32, except this time we'll go in the opposite direction. You should be left with a rough diamond shape with the lines crossing at the corners. So let us see. For number 3, we represented it by blue lines, and for number 2 represented it by red lines. So take note, we use blue lines for the tens, and for the ones we use the red lines. Okay, to calculate the product, we just need to count how many times all of the lines intersect and write each number under the diamond. We must start from right to left. So let us have it. Okay, let us start from the right. So that one. So let us count. 1, 2, 3, 4. So that's 4. Next, the middle. So we have 1, 2, 3, 4, 5, 6, 7, 8. So 8 for the middle. Next, and at the left, 1, 2, 3. So we have 384. So therefore, 12 times 32 is 384. So you can try solving it. It will yield the same answer, 384. Okay, let us try again another one. For instance, we have 24 times 43. Again, the numbers are represented using place value. 24 means 2 10 and 4 ones, or 2 tens and 4 ones. 43 means 4 tens and 3 ones. Again, let us draw diagonal lines corresponding to tens, and then leave a gap, then draw more lines in parallel to represent the ones. Again, we'll be using different colors. So for number 24, So for our tens, two tens, we represent it by the blue colors. And for our four ones, we're going to represent it by the red lines. Next. Okay, let us now do the number 43. Again, we'll be doing this in the opposite direction. For our four tens, we'll be using again the blue lines. For our three ones, we'll be using the red lines. There you are. So now, to calculate the product, we just need to count how many times all the lines intersect and write each number under the diamond. Again, we're going to start from right to left. Okay, let's start from the right. So let us count. 1, 2, 3. Let us count the intersections. 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12. And since that we have 12, we just bring down 2 and then we just add the tens to the middle. So we just have the remaining digit is 2. Okay, then at the middle, we just count the intersection again. The upper intersection, we have 6. And the lower intersection, we have 2, 4, 6, 8, 10, 12, 14, 16. So 16 plus 6 is 22, plus 1 is 23. So again, we just leave the ones. That's the explanation. Since we have 1 from the right, add 22 plus 1. So we have 23. Since we also have 23, add 2 to the left and 3 remains. So again, the 3 will be remain and the other 2 will be added to the left. So let us count the left, the intersection at the left. So 1, 2, 3, 4, 5, 6, 7, 8. So we have 8. Since we have 2 from the middle, add this to the intersections at the left side. Then we have 8 plus 2 is equal to 10. So therefore, 24 times 43 rather is equal to 1032. Since we are familiar with two digits, let us now try multiplying three digits. Let us try 123 times 223. Again, let us bear in mind, let us not forget that numbers are represented using place value. 123 means 100, 2 tens, and 3 ones. And 223 means 2 hundreds, 2 tens, and 3 ones. So let us try solving it. We then draw diagonal lines corresponding to the hundreds, tens, and ones. So again, we can use different colors for our lines representing the hundreds, tens, and ones. So for our example, we have 123. So our 100 is represented by the first line, the black one, and then our two tens is represented by the blue lines, and our three ones is represented by the red lines. Okay, let's do the same with our multiplier. So we have 223. So for our 200s, it is represented by the black lines. We have two black lines. And then for our 210s, represented by two blue lines. For our 3 ones, represented by three red lines. So again, doing the procedure that we presented a while ago, let us start from the right to the left, counting the intersection. So let us start from the right. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9. Next, column. So let us count the intersection. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12. Again, let us add 1 to the next column or area, and then 2 will remain on that certain column. So next, we're going to add the third column. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13, but don't forget, we have to add the 1 coming from the second column. So 13 plus 1, we have 14. Since we have 14, let us add 1 to the next area or column, and 4 will remain. So there you are. Next, let us count the intersection on the next column. We have 1, 2, 3, 4, 5, 6. So we have 6, and again, since we have 1 coming from the third column, we have to add it to the fourth column. We have 6 plus 1, so the total is 7. So for the final column from the left, we have 1, 2. So we have two intersections. So therefore, 123 times 223 equals 27,429. Okay, let us have another example. 103 times 223. Again, uh, remember that numbers are represented using place value. 103 means 100, but no tens since it is 0, and 3 ones. 223 means 2 hundreds, 2 tens, and 3 ones. Okay. We're going to draw diagonal lines corresponding to the hundreds, tens, and ones. Okay, for the hundreds, we have 103. For the hundreds, let us represent it by the black line. So we're going to represent it by a one black line. Since we don't have tens, put one's area farther. So we're just going to leave the tens place, since our tens is 0 for 103. So we're going to represent ones by the red lines. So 3 ones. So there you are. So next, let's do the same with the multiplier, starting from the left to the right. So 223. So we have 200s, so represented by two black lines. For our tens, we have two blue lines. For our ones, we have three red lines. As you can see, we have no blue lines in our multiplicand because as we all know, we have no tens. That's zero. Let's start at the right side again, counting the intersections. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 intersections coming from the first column. So let us place it 9. Next one, the second column, we have 1, 2, 3, 4, 5, 6. So there are 6 intersections. Let us proceed. To the next column, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So for the third column, we have 9 intersections. Next column, so we have 1, 2. So for the fourth column, we have 2 intersections. And for the last, we have 1, 2 intersections. So therefore, 103 times 223 is equal to 22,969. That's all for my presentation, and thank you for listening.
That's amazing session, sir. We are obliged to you for your marvelous presentation and giving your valuable time. This session will be effective for our audience because you shared your intelligible knowledge with us. Thank you so much, sir.
Thank you.
Welcome, sir. It's time to move our next speaker. Our next speaker is Dr. Arnold Alvaro. He is the teacher 3 and completed doctorate degree of education. So please give a warm welcome to Dr. Arnold, sir.
Hello, good evening. So I'm Dr. Arnold Alvaro. So I'm teacher 3 from Gordon Heights National High School, School Division Office of Olongapo City. So I'm also from the Philippines. So I'm a mathematics major and I'm teaching in high school and I have part-time in college. So teaching again algebra, statistics, qualitative business analysis, and so on and so forth. So so I will discuss what my new invention about the Japanese multiplication of algebraic expression. So, so just listen, and then I hope this presentation would help our students. So in this time of pandemic. Okay. So let's start. Okay. So again, the title of my presentation is about the Japanese multiplication of algebraic expressions. So this is related to the first presenter's lesson. So the Japanese multiplication of two digits and three digits number. So again, my lesson is about Japanese multiplication of algebraic expression. So again, I'm Dr. Arnold D. Alvaro. So from Gordon Heights National High School. So SDO Olongapo City, so Philippines. So there are lots of ways to multiply algebraic expressions. However, no one ever tried to use Japanese multiplication method. At first, it seems like something out of a magic show, but math would never feel mystical to the point of confusion. And while magicians may never reveal their tricks, we think it's essential to lift the lead on just why this strange method's work is the only way to fully appreciate them. So is the Japanese multiplication method helpful in solving algebraic expressions? In the Japanese multiplication method, we are able to complete a multiplication problem by merely drawing a few lines and counting the points of intersections. Sounds too good to be true, right? So switching between representations is a great way for your child to test their understanding of a particular method. So it's one thing to know how to carry out a procedure, so like the long multiplication of algebraic expression, but it's only useful when your child knows why this method works. So once they make these connections between symbolic and visual methods, they'll be able to apply their full toolkit of procedures in different situations. So how does the Japanese multiplication of algebraic expressions method work? So let's try. So x plus 2 multiplied to 3x plus 2. As you can see, this problem is related to, again, to the presentation of the first presenter. So remember, the terms are represented using the general form. So x plus 2 means 1x and 2. And 3x plus 2 means 3x and 2. So in this presentation, I will use three boxes or three regions. Why three regions? Because we will start with um, we have the answer would be x squared, x, and the constant. So we then draw diagonal lines corresponding to the first term. So after leaving a gap, we draw more lines in parallel to represent the second term. So let's try this. So first, we have x plus 1, 2. So we have x plus 2. So all we're doing is taking the familiar general form of equation and making it visual. Now let's do 3x plus 2. Except this time we'll go on the opposite direction. You should be left with a rough diamond shape with the lines crossing at the corners. So we have x, so we have 3x, and then we have 1, and then 2. So now we have the representation of x plus 2, and then we have 3x plus 2. So to calculate the product, we just need to count how many times of the lines intersect and write each number under the diamond. So we must start from right to left. So let's start with a constant. We have x and then x squared. So again, let's start at the right. So let's count 1, 2, 3, 4. So we have x, sorry, plus 4. Let's go with the x region. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have positive 8x. So next, let's try the intersection at the x squared. So we have 1, 2, 3. Now we have 3x squared. So therefore, x plus 2 multiplied to 3x plus 2 is equal to 3x plus 3x squared plus 8x plus 4. So let's try again another problem. So we have 2x plus 4 multiplied to 4x plus 3. So remember that algebraic expressions are represented using general form. So we have 2x plus 4 means 2x and 4. And 4x plus 3 means 4x and 3. So again, we have two regions. We have x squared, x, and the constant. So we then draw diagonal lines corresponding to the first term. And after leaving a gap, we draw more lines in parallel to represent the second term. So let's try to do this one. We have 2x and then plus 4. We have 2x plus 4. So all we're doing is taking the familiar general form of equation and making it visual. So now, let's do 4x plus 3. Except this time, we'll go on the opposite direction. You should be left with a rough diamond shape with the lines crossing at the corners. So we have 1, 2, 3, 4. We have 4x and then another lines 1, 2, 3. So now we have the representation of we have 2x plus 4 multiplied to 4x plus 3. So to calculate the product, we just need to count how many times all the lines intersect and write each number under the diamond. We must start from right to left. So first we have the constant. We should count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 intersections. So let's write plus 12. So we have positive 12. Next, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So at the middle, we have positive 22x. So next, let's try to find the intersection at the third, at the left area. We have 1, 2, 3, 4, 5, 6, 7, 8. Now we have 8x squared. So therefore, 2x plus 4 multiplied to 4x plus 3 is equivalent to 8x squared plus 22x plus 12. Since we are familiar with the binomials, let's try binomials with a negative second term or constant. So let's try if it will work at this problem. So let's try. So we have x minus 2 multiplied to 3x plus 2. So remember again that algebraic expressions are represented using general form. We have x, that is x minus 2 means 1x and negative 2. So that's typographical error. So we have 3x plus 2, it means 3x and 2. So let's try. So we then draw diagonal lines again, corresponding to the first term. After leaving a gap, we draw more lines in the parallel to represent the second term. Since our second term is negative, let's try, or we should use another color. So we have x again. So our problem is x minus 2. So x, and then we have 2. So again, we will change the color. So we have the blue lines, and now we have the red lines. So we have x minus 2. Then next, all we're doing again is taking the familiar general form of equation and making it visual. Now let's do 3x plus 2. So we have 1, 2, 3. 3x, and then let's put a gap, and then that is 1, 2. So we have the representation of the problem. We have x minus 2 multiplied to 3x plus 2. So to calculate the product again, we just need to count how many times all the lines intersect and write each number under the diamond. We must start from right to left. So let's try. Let's start with the constant. So let's start at the right. So 1, 2, 3, 4. As you can see, we have two different colors intersecting. So since there are two colors in the intersections, the answer is negative. So we have 1, 2, 3, 4. So what that would be, the constant is negative 4. So let's go with the middle. 1, 2, 3, Okay, let's count one, two, and then to the other at the bottom we have one, two, three, four, five, six. As you can see at the topmost area, we have the same color. So that is positive 2. At the bottom part, we have two colors intersection. So therefore, that would be again negative. So since we have two colors in the intersections to the bottom, it would become negative 6x. Add it to positive 2x, and then the answer is negative 4x. So our answer for that is negative 4x. Then at the left, so we have 1, 2, 3. Since they have the same color, so that is positive. So we have 3x squared. So now, therefore, x minus 2 multiplied to 3x plus 2 is equal to 3x squared minus 4x minus 4. So do you have question? So let's try again. So we have 2x minus 4 multiplied to 4x minus 3. So remember again that algebraic expressions are represented using general form. So we have 2x minus 4 means 2x and negative 4. Then 4x minus 3 means 4x minus 3 and negative 3, sorry. So we then draw diagonal lines corresponding to the first term. We have 2x minus 1, 2, 3, 4. So we have 2x minus 4. So all we're doing now is taking the familiar general form of equation, making it visual. And now let's do 4x minus 3, except this time we'll go on the opposite direction. You should be left with the rough diamond shape with the lines crossing at the corners. Let's try 4x minus 3. 1, 2, 3, 4. We have 4x, and then let's leave a gap, and then we have to put red lines. We have 1, 2, 3. So now it represented 4x minus 3. So that is the representation of the problem. 2x minus 4 multiplied to 4x minus 3. So to calculate the product, we just need again to count how many times all the lines intersect and write each number under the diamond. We must start from right to left. So let's start again on the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So as you can see, we have only one color intersection that is red. Even it's red, even it's negative, if we multiply it to negative, it would result to positive. Again, for this one, if we have intersections so with the same color, it would be positive. So the answer, so since there are the same color in the intersections, the answer is positive. So our answer is positive 12. So next, we have, as you can see, in this figure, see we have intersections of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. As you can see, at the top and the bottom, there are intersections of two colors. So since we have two intersections of different colors, so that is negative. So then at the middle, so that there are two colors in the intersection, but at the top and bottom, just add the answer, and the answer is negative. So we have negative 22x. So let's go at the left. So let's count 1, 2, 3, 4, 5, 6, 7, 8. So our answer is 8x squared. So therefore, 2x, sorry, that is 2x minus 4. So 2x minus 4 and then 4x minus 3. So that is typographical error again. So that is minus. So answer is 8x squared minus 22x plus 12. So since we are familiar with the binomials, let's try trinomials. So as you can see in our in the present in the poster, okay, I have to discuss binomials and monomials, but I think multiplying binomials and monomials is very easy. So let's try this difficult one, that is binomials. Sorry, multiplying trinomials. So let's try. We have x squared plus 2x plus 3 and multiply to 2x squared plus 2x plus 3. This is different from binomials. Why? Because we will have, again, 5 regions. Why 5 regions again? We have x to the fourth. As you can see, we have x to the x squared multiplied to x squared. That is x to the fourth. So that is, we have 5 regions. Why? We have x to the fourth, we have x cubed, and then we have x squared, and we have x, and last we have constant. So that's why we have 5 regions. So we then draw diagonal lines corresponding to the first term, second term, and the third term, or the constant. First, we have 1, 2, 3. So we have 3, so we have x squared plus 2x plus 3. So let's do the same with the multiplier. 1, we have 2x squared plus 2x plus 3. So now we have representation of x squared plus 2x plus 3 multiply to 2x squared plus 2x plus 3. So let's start at the right side. So again, we will count the intersections starting from the right side. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have the constant is 9. So again, since there are intersections of same color lines, so the answer is positive. So next, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12x. So we have positive 12x. Next, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have positive 13x squared. Next, we have 1, 2, 3, 4, 5, 6. So we have 6x cubed. And then last, we have 1, 2. Then we have 2x to the fourth power. So therefore, x squared plus 2x plus 3 multiplied to 2x squared plus 2x plus 3 is equal to 2x to the fourth plus 6x cubed plus 13x squared plus 12x plus 9. So let's try again, try another one. So we have negative. So again, remember that algebraic expressions are represented using general form of an equation. So you have x squared plus 3 means 1x squared. We have 0x. So again, as you can see, we have x squared plus 3. That is, it means we have 0x. And we have 3. So we have 2x squared plus 2x minus 3. It means we have 2x squared, and then we have 2x, and we have negative 3. So we then draw diagonal lines corresponding to the first term and the last term. Since we don't have x, put last term one area farther. So we have x squared plus 3. So let's do the same with the multiplier. We have 1, 2. We have 2x squared plus 1, 2, 2x, then minus 3. So we have now, since we have the negative constant, we will change its color. So the color is red. So let's try. So let's start to the right side. We will count. 1. Count the intersection. 1, 2, 3, 4, 5, 6, 7, 8, 9. As you can see, there are intersections of different colors. So therefore, we have 9. So on our answer, since that is this, we have different color, negative 9. So the answer, negative 9. Next, let's try. 1, 2, 3, 4, 5, 6. So the same color. So we have positive 6x. Now, let's count. 1, 2, 3. So the same two colors. So negative. So let's try at the bottom. 1, 2, 3, 4, 5, 6. So since we had two colors of intersection at the top, it becomes negative 3. Therefore, negative 3 plus 6 equals positive 3. So our answer is positive 3x squared. So next we have 1, 2. So, so we have positive 2x cubed. So let's try x to the fourth section. We have 1, 2. So we have 2x to the fourth. So therefore, x squared plus 3 multiplied to 2x squared plus 2x minus 3 is equivalent to 2x to the fourth plus 2x cubed plus 3x squared plus 6x minus 9. So that is my presentation and our presentation about multiplication of algebraic expression. So as a background of this one, okay, again, so we start with the multiplication, uh, sorry, Japanese multiplication. So then using this Japanese multiplication, I derive another technique in algebraic expression, which is again, I named this one as the Japanese multiplication of algebraic expression. I hope this technique will help you a lot, especially again, since our students is in studying at home. So therefore, this would help them as this is uh, what do you call this? Self-learn. This will serve as a guide to our learners who wants to learn mathematics. So that's all. So let's try to answer our kahot. So, ma'am, so are you ready for the kahot? So for those who have kahot, so let's try this. So 8036871. So moderator, how many minutes will we allow the the participants for this quiz competition? Hello, moderator.
Hello, sir. I'm there.
Yes. We're just waiting for the player, sir.
Yeah,
So we
no
don't have
problem.
any.
No problem.
We have one player.
Yeah. Rendro Vaira, he's already a winner of previous quiz.
Yeah.
Kahoot ready. Today we have enough time, so no problem about joining. So
Yes.
we'll allow some more time for joining.
Yes, sir. So if you have question in my presentation,
Okay, no, sir.
again,
After this quiz, we'll go through
yes,
the for Q&A
yes, sir,
with
yes, sir,
Dr. Clarence also.
yes, sir. So we have 65, so let's wait. So since we have more time,
Yes, we have today more time, so we'll wait some more time.
let's wait for them. So for those who don't have Kahoot, you can download it at Play Store. Just type Kahoot and then you will have the Kahoot app. Again, you can also search in Google, and then if you found Kahoot, and then you can also play Kahoot there, Google. So we have 94 participants. Let's wait. 97.
Okay, sir. I think let's start. What do you
Let's
think?
start, sir. Okay.
Yeah.
I think we should wait for another 5 minutes, sir. Is it okay? Or
Okay.
we
Okay.
just
No.
start?
Okay. No
Okay.
problem. No problem.
Since we only have
Oh,
103.
oh, okay, sir. In between 5 minutes, please do the interact with our participants.
Yes, sir. We have 30 seconds. Okay, sir. So let's start. Hello, sir. So let's start. So we have 103, 104, 105 participants. So let's wait for the signal.
Let's start.
Okay, let's start, sir. Okay,
Yeah.
so we have 112, 113 participants. So let's start the game. So the title of the game is Japanese Multiplication of Algebraic Expressions. So let's try. Okay, first, what is the Japanese multiplication model of the picture below? So you have 1 minute. Okay, so answer is 53 times 21. So we have 60 uh, correct. Right. So next, so we have Randolph, Biraya again. Congratulations, Randolph. Next question. So what is the Japanese multiplication model of the picture below? Is it 35 times 12? Is it 35 times 21? Is it 53 times 12 or 53 times 21? 7, 6, 5, 4, 3, 2, 1. Again, we have 60 correct answers. So 35 times 12. So Joyce, 1972 score. So we have 3 out of 10. What is the Japanese multiplication model of the picture below? Is it 323 times 121? Or is it 332 times 121? Or is it 121 times 232? Or 233 times 121? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have 21 correct answers. Next. So John, 2,580 points. Next, 4 out of 10. What is the Japanese multiplication model of the picture below? Next, 5 out of 10. So what is the Japanese multiplication model of the picture below? We have 51 correct answers. Next. So again, what is the Japanese multiplication model of the picture below? So we have 3x plus 5 multiplied to x plus 2, or 5x plus 3 multiplied to 2x minus 1, or 3x plus 5 multiplied to 2x plus 1, or 5x plus 3 multiplied to 2x plus 2. So what would be the answer? 7, 6, 5, 4, 3, 2, 1. We have 16 correct answers. Next, we have 7 out of 10. So what is the Japanese multiplication model of the picture below? Is it 4x minus 4 multiplied to 2x minus 1? Or 4x plus 4 multiplied to 2x minus 1? Or 4x minus 4 multiplied to 2x plus 1? Or 4x plus 4 multiplied to 2x plus 1? So we have 63 correct answers. Or Gem is leading. So next, 8 out of 10. What is the Japanese multiplication model of the picture below? So we have this. Is it 4x plus 4 multiplied to 3x minus 2? Or is it 4x minus 4 multiplied to 3x minus 2? Or is it 4x minus 4 multiplied to 3x plus 2? Or is it 4x plus 4 multiplied to 3x plus 2? We have 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Time's up. We have 13 correct answers. Next, we have ninth question. So what is the Japanese multiplication model of the picture below? Is it 3x plus 4 multiplied to 3x minus 2? Or is it 3x minus 4 multiplied to 3x plus 2? Or 4x minus 4 multiplied to 3x minus 2? Or 3x plus 4 multiplied to 3x plus 2? 8, 7, 6, 5, 4, 3, 2, 1. Time's up. The answer is blue. So we have 65 correct answer. So last question. So leaderboard, we have Reese. Next, last question. What is the Japanese multiplication model of the picture below? Is it 3x squared plus 2x plus 3? Or 2x squared plus x minus 1? Or is it 3x squared plus 2x minus 3 multiplied to 2x squared plus x minus 1? Or is it 3x squared minus 2x minus 3 multiplied to 2x squared plus x minus 1? Or 3x squared minus 2x minus 3 multiplied to 2x squared minus x minus 1? Who would be the winner for this quiz competition? So we have 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Time's up. So the correct answer is red, 51. So we have third place, we have JB Pogi. And we have second place, we have Gem B. And then Reese is the winner. So the score of 8,371. So we have 2 out of 10 correct answer. So congratulations to Reese, Gem, and JB Pogi.
Both answered 10 out of 10.
Yes, congratulations.
Congratulations. Both of them first, second, and third. It's a simple request to you that contact with our page inbox directly with your full name and gender to issue the certificate immediately. So it's a request with submit your full name and your gender, then we can issue your certificate immediately. Congratulations again, first, second, and third, and congratulations all who participate in the quiz competition. Now I think it's back to the Q&A. So Dr. Clarence, I think you are here. Yes, sir. Now I think we should go for the Q&A.
So so the question. So let's start with, is there available Japanese multiplication available Japanese multiplication math book for students? So my answer for that is this Japanese multiplication, okay, Japanese multiplication using and three digits number is already in the YouTube. But this Japanese multiplication of algebraic expression, as I said earlier, this is my new invention. So I invent this technique so that it would help, okay, our students during this pandemic. So again, we can find this Japanese multiplication of algebraic expression in any book, mathematics book, but we can use this Japanese multiplication of algebraic expression as I discussed earlier. So thank you. No question, just want to say thank you. So thank you. Okay, so this is the first time I encounter such awesome technique in multiplication. Thank you to the speakers. Keep safe and God bless you. Yes, Carmela, this is a once in a lifetime experience. Hello, sir. Can we use that method in multiplying higher degree polynomials? Yes, but I've said earlier, so since if we are multiplying, example, we have x to the fifth, then multiply to x to the x, for example, x squared. So we have since we have x to the fifth, we have 5, and then x squared we have 2, and then another constant, we have 8 regions for this representation. So yes, you can use it. So how to put a line if the expression has an exponent like x squared or x cubed? Uh, as I've said earlier, so if you have x squared, so if you have to, for example, you have multiply x squared and x cubed. So we have seven regions. So we have x to the fifth, x to the fourth, x to the third, x squared, x, and constant. So we put line, okay, we put the line, for example, we have x squared. So we first, that is x squared, we put it in the upper, and then the next one is we should put it in the constant, or sorry, if you have x, put the gap, and then put another line, and then for the constant, put the gap again, and then put another line. For x cubed, so again, we have to put um, x cubed at the lower, and then put x squared again after the gap, and then x after the gap, and then constant after the gap. So that is the answer for question cards. So does the Philippine education already taught Japanese multiplication math in some tertiary education and in secondary education? As I've said earlier, this is an invention. So this is my invention. So this is not yet not yet taught in Philippine education. So this is only what do you call it? This is modification of the Japanese multiplication, as we can watch it in YouTube, TikTok, and other social media apps. Is Japanese multiplication applicable in multiplying large integers? Yes. Okay, but the question is, if we did there are large numbers or large integers like, for example, 121. We can't. There are lots of lines for that. So the one method that I use is that um, representation of a number. It's representation of a number. Do you have a blog on this method, sir? No, man. This is the first time of presentation of this Japanese multiplication of algebraic expression. How do you determine the columns to be used? Yes, ma'am. For example, thank you, Ma'am Maxi Lumunyo, my head teacher in mathematics in Gordon National High School. So again, to determine the columns to be used, for example, ma'am, you have x squared and multiply to x cubed. So x squared, we have 2, and x cubed, you have 3. So 2 plus 3, you have 5, and then add the constant, so you have 6. So you have 6 regions or columns for that one. So can we use Jogyuk Kin Q lesson study? I'm not familiar with this Jogyuk Kin Q. So lesson study. Sorry. So can we apply that also in multiplying special products? Yes, ma'am. Yes. So since we can do representations. We just need to pass through the instruction. So we can go back for this video and then let's try what is the instruction for this one. And if you do have question, you can uh, comment here and then I'll try to answer your questions. Object try teaching multiplication of algebraic expression having a fraction as coefficient. So this is not applicable for this fraction. So since uh, we just representing it with lines. So this is only for whole numbers. Other questions? The question. Since we use different colors for positive and negative, it is applicable to use paper and ball pen solving such algebra. Yes, ma'am. Sorry. Alan Earl Caliano. Yes, sir. You can use it. Using two, again, you can use the different color of ball pen. So we have ink ball pen. So you can use black, blue, and red. Supported. If you have algebraic expression, two expressions only, you need two color ink. So you can use blue or black or red. So just remember, you just does it needs to have a column for each term in the product of algebraic expression? Yes. I tried it without the column and got the correct answer for as long as you the highest degree of the product of two first term because it is quite confusing. For this one JC, so this is a guide, okay, so that uh, you could just count the intersection between that region in that region. Sorry.
Amazing session, sir. Dear knowledge seeker, I would love to thank you all from my deep heart for attending today's session. Hopefully, you learned something new and you will implement in your life. Please leave a review, a recommend on our page if you learned something or we helped you a little bit. Please spread the information with your friends. Thank you so much. Stay happy, stay safe.
Thank you so much. Thank you so much, dear Dr. Clarence and Dr. Arnold, for your beautiful time and beautiful presentation. Already we completed our 85th webinar by this. So hopefully our participants who already enjoyed. Hopefully you guys also enjoyed. What do you think? Is that I told it clearly or not?
If you have question,
Sir, is to we. Hello, sir. Am I audible?
sir.
Sir, am I audible? Aksha, can
Yes,
you
sir.
hear me?
Yeah, yes, yes, sir, yes, sir.
Yeah, I already told that our participants already enjoyed a lot.
Yes,
On the other side, what about you? You enjoyed or not?
I enjoyed that. We enjoy it.
What about Dr. Clarence, sir?
About you, Sir Clarence? Did you enjoy Sir Clarence?
I think when he tried to unmute himself on that time, some echo occurred, right? Okay, sir. Uh, Not two more. Thank you so much. Thank you so much for your beautiful presentation and beautiful time. Just give me a moment. Give me 3 to 4 seconds to show the certification process. Is always the same. Class code not required. You can. I already shared the certification link into comment box and also pinned into comment section. So this is the time. Thanks you once again, Dr. Clarence and Dr. Arnold sir, for your time. Arnold sir is the this is your second time of speech.
Yes, sir. It's very uh, I can explain my feelings right now, but
Yes, sir.
I'm
Yes.
happy sharing my knowledge, especially this one.
And one more thing is that for our participants, our next webinar will be held on 25th April. The topic is modern perspectives in language, literature, and education. It's also great, amazing. It would be a great, amazing topic for next day after tomorrow. See you soon, all there. Hopefully, you will all attend the session. And for those who are asking, who are already in asking for comment section, that certification process I already shared in screen, and our customer service representative like Janet Cablo, and another one is Kelvin, who are always ready to serve you. So no problem. If you have faced any kinds of problem, that directly you can contact with our also page inbox. So thank you so much. See you again in the next session. Thank you. Thank you so much.